Programming Throwdown, episode 150, Code Reviews with On Freund. Take it away, Patrick.
Well, we have a divisible by 10 episode, 150, so that's got to be a positive sign. We made it another, it's not an anniversary, I don't know what we call it, another...
Decaversary?
Jubilee.
Oh,
Nice.
Oh, that's true. Oh, okay, too soon. Anyways, so we're here to talk about code reviews, which is an awesome topic. Even in the pre-show, I was getting a little excited just hearing some of the thoughts from our guests today. So rather than tee it up and just make everyone really excited, you're already here. So we'll just go ahead and go into it. I don't need to pitch an episode coming out next week. It's here. It's now. We're here with On Freund, who is the co-founder and CEO of Wilco. Welcome to the show, On.
Thank you so much. Great to be on board.
So before we get into the topic, although I'm pretty geared up, I'm not going to lie. I talk a lot about code reviews. So before we get there, let's talk a little bit about you. So we try to ask a lot of our guests. I think it's really interesting. Maybe it's just a very vanity project of mine to sort of that's not the right word. Anyways, to just understand a lot about other people and how they sort of developed and got into their current roles. But tell me a little bit about, do you remember your first exposure to tech? Like the first time you wrote a program or the first time you got a computer, just that memorable sort of early thing that happened?
Yeah, it's a great question. If that's your vanity project, you're on the right track. So I think I was around 8 years old. I wrote my first computer program in BASIC. And back then in Israel, there was a famous series of booklets about how to write BASIC. It was called Machshevet. Everyone who wanted to do anything with a computer in Israel had it. And it was a series of, 15 of them or so. The first one was obviously the Hello World program, but then very quickly it progressed. And I actually loved writing games from day one, whether they were text-based or at some point, with actual graphics. But that was always something that drew me even more than playing games. I think writing games was something that I found really cool.
Awesome. I think 8 is a bit on the earlier side than a lot of you guys, earlier than mine. But this is interesting. So there's a booklet. Was the booklet a sort of workbook or just a sort of copy and paste examples? I mean, both are kind of interesting. But what was kind of the contents?
So a lot of it was copy and paste, and the literal sense that you look at the thing and then you type it. But a lot of it was fill in the blanks, and some of it, towards the end of every booklet, you'd usually get something that's a bit more adventurous, and you had to start from scratch and build something meaningful.
That's awesome. That's not uncommon, actually. This I guess today you would literally go to the website and just highlight it and Command C or Control C, Command V, Control V. But I think this thing you said, it was true for me as well. Looking in an actual physical book and having to, without errors, type in something and see the magic and debug it. And the booklet thing, I don't know of any, in the United States, any sort of booklet for computer science. But there's a famous one for electronics, which is Forrest Mims. That's even pretty. Why that been I want to say, I was going to guess the decade, but I'll be wrong. So I'll have to look it up later. But in Radio Shack, which was a small chain of electronics hobbyist stores for early computers, they would have these little booklets of circuits. So timers using the 555 integrated circuit or whatever. And it's kind of like what you were saying. People would sort of look at them and you could put them on your breadboard and poke in the little things.
Yeah.
And, Radio Shack sold.
Doing that as a kid. Yeah. I had all of those, electronic kits where you build your own alarm system or your radio or whatever, AM radio. Yeah, that was cool. I love those.
Yeah.
In Canada, we had, I don't know if we had this in the US too. We had these books where it was you'd basically read through this story, and at some point the story would pause, and in the book there would be all this basic code that you would have to type into your computer. And the basic code would include some interactivity. So it would ask you type in this number and then do this with it to try and solve this little puzzle. And then once you got the answer, you could flip to the next page. And then when you got to the next page, they just assumed you got it right. It's like, you're right, it's 21. And half the time I would type it in wrong, and it would be like, oh, it's 21, but I got, syntax error 13. Well, all right, let's keep going. And so but it's really fun.
That's awesome. I love those things. If you ever manage to pick up on the name of those books, I'd love to get my hands on a
Oh, let
copy.
me see if I could do some digging. It would be some great nostalgia.
So that's pretty. I thought you were going to tell us like a super clever choose your own adventure. Like if you put your answer, go to that page number, and then there'd be like a little debug thing, like, oh, you got 17, you messed up order of operations,
So you're off by 1. This page was intentionally left blank.
Oh, yeah, okay. All right, so you're 8, you're copying stuff from these books and learning basic. I mean, it's awesome. Did you kind of fall out of it for a while, or did you just kind of continually do some amount of programming through to college? Like, what was your sort of path there?
So I did some amount of programming throughout school. In high school, we actually had this thing where in Israel, you have to volunteer for something during high school in at least one of the years. And there are specific things that you can do. And a friend of mine volunteered for like this sort of nonprofit that is working on road safety. And he was supposed to build a game, like a board game for kids where that teaches road safety. And he reached out to me and said, what if I build a video game? So in addition to my volunteer work, I actually ended up working on his too. And we worked together. He was really good with graphics. I was good with writing code. And we built this cool game. It had like several levels. And the first one was like a walkway. And every time you got the answer right, you would advance to the next block of it. We're not going to talk about what happens if you got it wrong. And the second level was you're like roller skating, and you get to street signs, and you have to make out which one it is. I don't remember the third level. We actually got together like a few months ago and talked about it. But then after that, it was really cool. We decided, all right, let's build another game. And this one was like a fighting game, like Mortal Kombat style, which was really hot in those days. And we filmed one of our friends against a white sheet. And he kind of went pixel by pixel to get just the guy. And we filmed him like, giving out punches and kicks and all of that and jumping in the air. And we got to a point where we have our friend against like a sketchy bar backdrop, and you can make him jump, you can make him kick, you can make him throw a punch. And it was really cool. We never got to the stage where there's another player, so you could just move this guy around and that's it. But it was fun.
Yeah, that sounds awesome. Just for posterity's sake, the series is called Micro Adventure, and it was actually an American thing. It was published by Scholastic. But if folks want to look that up, you read these micro adventure books, and they have to solve little basic programs along the way. But similar to you, I also made a bunch of video games. The most infamous one was arm wrestling, where you had to hit the space bar so many times per second to for so many seconds to arm wrestle victory. And the computer
awesome.
lab, they broke 3 keyboards, and then that game got banned. But I wonder what the equivalent is for nowadays for kids who are, that the age that we were back then. Like, what is this thing they're tinkering with now? But I'm not sure.
They create videos on TikTok.
Yeah, that's probably. But is that to the same level of like I guess it is kind of a technical thing. Like it can lead to more technical stuff later, like video editing.
And it all depends on how far they take it, right? Some of them get really professional and throw in some really cool things, but it's not completely programmable. Maybe I'm blanking on the name. The block thing.
Minecraft and Roblox.
Minecraft, exactly. Yeah. So maybe Minecraft and Roblox are the closest equivalent these days.
Yeah, it makes sense.
So for your fighting game, I'm not sure if you were aware at the time or even now, but that description of how you did, I mean, that early motion capture video, whatever, is how the original Mortal Kombat there was some video a few years ago that I think came out where they were
Yeah,
showing
yeah.
the person like doing the scenes of that ended up in the video game. So I don't know, did you guys know that, or did you like independently just like have this idea?
Well, we assumed. Yeah, I only caught that video like 3 months ago, I think, and we're talking about more than 20 years back. But
Sure.
we did assume, Mortal Kombat looks like these characters were videoed, so we assumed that's what was happening, and we did know about the green screen technique, but we didn't have anything green, so we just went with white. We had to dress him up in very dark uniform to make sure that he stands out against the white background.
No, but that problem solving, right? I mean, like interdiscipline problems. I mean, that's actually like really awesome. And I can totally see like how you end up in a career in tech if that's the kind of things, even if you don't know that's where you're going, if that's the kind of things you're doing, like it just feels like a natural follow on, in my opinion.
Yeah, I agree.
Okay, so you're in high school helping volunteer stuff, doing this. And then did you end up studying computer science or related field in university?
Yeah, I did. I went to Tel Aviv University. I studied computer science, which in retrospect has nothing to do with programming. It's computer science. These are very different topics. I enjoyed every minute of it. Don't get me wrong. I think computer science is a fascinating topic. And at some point, I was contemplating continuing a more academic path and actually doing computer science as a career. But when I got my first real job, I realized that actually nothing that I've learned in college has any bearing towards what I do at work.
I think this thing you're saying might be is definitely true, but it might be a sort of revelation to some people that like going and getting a computer science degree doesn't make you a programmer out the other side. Do you want to elaborate? I mean, I'm happy to elaborate too, but I'll give you the opportunity since you're the guest. Do you want to elaborate like why one isn't equivalent?
Sure. So first of all, I'll start by saying that I do recommend people get a computer science degree because I think, like I said, it's awesome. It's interesting. It's a fascinating topic. There are a lot of subtopics within it that you could explore. So, different tastes, etc. It's super interesting. And at some point, you might be using some of the tools that you've picked up in college in your job, but it's usually, few and far between. But most of what you learn in school is very theoretical. It actually has nothing to do with computers. Computer science is eventually a branch of math, and large chunks of it deals with hypothetical computers with tapes and operations. So what you learn doesn't necessarily prepare you for the job. And I guess even more importantly, the few things that you do learn that are meaningful are all about code. And the work of a software engineer is way more than code. There are so many skills that go into what you do on a daily basis, whether it's soft skills, whether it's hard skills. There's just so many of them, and you don't touch any of them in college.
Yeah, I agree. I think there's maybe an obvious, but this tension between, as you sort of saying, sort of the mathematical, or I don't want to say philosophical, but almost that bent of sort of how to think about programs as a conceptual sort of underpinning and actually coding or programming. And depending on your university, there may be a balance between them, or even different degrees or specialties within the degree that have you doing more of one or more of the other. But I think like you're mentioning, you could take an image processing course and learn all about like theoretical, like binary thresholding of images and never open up OpenCV. And if you go do image processing like on your own, you're like immediately going to go into a library and sort of be doing image processing tasks. And some universities have tried to adapt to match the expectations, but some have said, wait, that's not our business. Like our business is the business of teaching sort of like you're saying, Turing machines, or the theoretical differences of a von Neumann architecture versus something else, or talking about compiler languages as like abstract syntax tree manipulation, not sort of the brass tacks of optimization. And so really kind of, I think that's part when you choose a university, that's like a decision you're making when you're choosing what focus you're going to have. But what I, having now being in the role where I interview people coming out of university for working on teams that I'm on, and learning is a couple things that, one, not everyone, even at the end, is realizing that they aren't coming out automatically as a programmer. It's not just telling me their curriculum or telling me, even if they did programming as class projects, that's not going to sell me enough on them. That doesn't teach me that they're going to hit the ground running or help me feel confident they're going to hit the ground running. And most of them don't realize, although I have had some candidates kind of self-aware say it, that, hey, there's a big difference in university. It's all throwaway. There's like a scaffolding and I do a little fill in the blank. We were kind of talking about that. And then it goes away. Maintenance isn't a concern, even though we might talk about it, but there's no practice of maintenance. You work on a quote unquote team, but the dynamics, the economics of it, everything is just different. And so maybe it hints at what it would be like. But some people have internships have that realization. Some have internships, don't quite. But it's just this interesting sort of mix of people and how prepared they come out. And often it's because of work that they took on their own or on the side and not the curriculum.
Exactly. And, you come into the first day on the job and you're in the office and, the person welcoming you is probably going to say, hey, why don't you familiarize yourself with the rest of the team? And guess what? You've never learned anything about teamwork. Maybe there was like a project that you had to do in a group of 4 where, 2 of them were too high to participate and the other person was, banking on you to complete the entire project. So you never really learned how to work in a team. And then maybe go familiarize yourself with the build system. And you're like, wait, what is a build system? I've never done that. And this is the way our CI/CD pipeline works. And like, wait, what? And oh, by the way, we're using Git. And like, what's Git? I've been doing everything on SVN and CVS.
Oh, awesome. Okay. All right. Well, maybe we keep going because we can't stop here. We can't pull over the train here and take the train stop. So we'll keep going. All right. So you're studying in university, computer science. Did you kind of like do internships or did you just kind of focus heads down and get through and then enter the workforce? How did that? And you said you were considering academia.
Yeah. So I was actually very, very fortunate. So second year, third semester of school, there's like a career fair. And it was actually meant mostly for electrical engineering majors. And it was meant for like, seniors. But last minute, I say like, what the heck? Let me go there and see what's happening. So I go and I'm late because, I wasn't intending on going. So I'm late. The guys are like folding up the booth of a company called Applied Materials. And I'm like, oh, I'm too late. And the guy that was doing the interview is like, hey, let me ask you a couple of questions. Let's see if it makes sense. And all of the questions he asked me were about operating systems. And I just happened to come out of operating system class like that day. And all of the questions he asked me were fresh in my brain. So he's like, what's a context switch? And which, by the way, developers today probably don't even know what it is, but because they're lucky enough to be in higher level languages. But what's a context switch? And I look at him and I'm like, are you kidding me? Because it's so fresh in my brain that I think that it's common knowledge. Are you kidding me? And he's like, no, what is it? And so I give a perfect answer, and he's like, so he writes down, and I know this because he told me afterwards, he writes down very cocky, but knows his stuff.
Fair assessment from the sound of it.
Yeah, in retrospect, he got it completely right. We're actually very good friends now till this day, and this was, almost 20 years ago. So he writes this down in his notebook, and then a few days later, I get a call, and they're like, why don't you come over for an interview? And I interview, and I managed to get the job, and I start working. This was like, in the break, the winter break between the third and fourth semester, I start working. So I never really had an internship per se, but I was working throughout the second half of my degree.
Oh, awesome. So you were like working part-time while doing school?
Yeah.
Oh, nice. Oh, and so that company, they were pretty low level if they were asking about operating system and context switching?
Yeah. So Applied Materials is in the semiconductor industry. Okay. And what they do is they make machines that either build or test or do anything in the manufacture of chips. So specifically, the team that I was working on was building this machine that could do two things. This was like an attempt to take two machines and turn them into one. So there was one machine that is measuring, say, the distance between two conductors to make sure that the board was printed right. And we're talking those distances. Obviously, it's microns, right?
Sure.
So there was like this crazy electron microscope and all of that. And the other machine was classifying defects. So that there is a defect in the wafer that you're looking at. A wafer is like a collection of a lot of chips. It's like a circular disk. So the second machine knows there's a defect and tries to classify it, so what happened wrong during the manufacturing process. And we were building a machine that is trying to do both. So there was a lot of image processing. There was a lot of controlling the machinery. You had like basically a robot that is taking one wafer while taking the other wafer out, because you didn't want to waste time. This is like the manufacturing floor. Everything needs to be super efficient. So you had these arms that are bringing in one wafer, taking the other one out, and there's like a chamber in between where they it's like those spaceships where you need like a double latch.
Oh yeah, it's got to be vacuumed down.
Yeah, because everything is like super clean. You can't have any particles of dust in there. So it was pretty wild and pretty low level. It was fun, but I vowed not to do low level since, and I, like many promises I made in my life, didn't actually live up to it.
Okay, good. So you and I can't be friends, but okay, keep going on. So we won't get sidetracked there either. So you're doing this, you're finishing up your degree, and then it sounds like maybe you decided not to go there when you graduated, or kind of take us through what happened next.
So when I was close to graduation, I decided that applied materials is no longer for me. Applied Materials is a Fortune 500 company. It's huge. It's American. I wanted to join an Israeli startup. I'm based in Israel. I want to be where decisions are being taken, etc. And I joined a small startup. It was about 20 people. It was in the cybersecurity space. And I joined the server team because I didn't want to do low level anymore, right? So I'm on the server team. I'm writing .NET code, and no need to manage memory, all of that. And what we were doing is this product that lets CISOs control what's happening in their organization in terms of external devices and content. So can't copy those files over to a USB, can't send that type of content over email, et cetera, et cetera. And what do you know? Within a year, I find myself in the agent team writing Windows kernel drivers.
It sounds like you didn't last long in your avoidance, so you must have some skill there, I guess.
I hated it. When you write Windows kernel drivers, today it's somewhat easier because a lot of it could be done with virtual machines. But because we were dealing so much with hardware, many of the things we did actually meant that we had to have another computer to test what we're building on. And your actual computer and the other computer are connected through a serial cable, because that's the only way to debug kernel drivers. And any bug, or almost any bug, would cause a blue screen of death. And sometimes the cycle of blue screens of death, where you actually have to wipe the hard drive clean and start from scratch. And this was just that's where I learned the importance of a really short feedback cycle. When you're writing a driver and everything that you do wrong takes you like 2 hours to, get something new on that computer to test it again, it's just so frustrating.
Yeah, I think also the other thing that you're mentioning, which is kind of interesting, like nowadays or most development, I guess, takes place in an app running in your computer. And the goal of the operating system in part is to prevent the app from crashing the operating system. Or one of the many goals. But this level you're talking about is lower than that. So those protections aren't in place for efficiency reasons, for whatever. And over time, they've tried to kind of get better at it, as you've said, or you can use a virtual machine, a machine running in your machine. But the same is true largely of all embedded development. So if you're on a small ARM core or a MIPS processor of some sort, like you're over some serial cable or USB to a tiny little board. And if you screw up, who knows what's going on? You're trying to get commands out. You're probing it with a little multimeter or an oscilloscope, trying to move a line up and down to say that you're alive and still running.
The one thing they do have going for them is that boot times are faster. Other than that, it's just like those days of Windows drivers. But Windows could take 2 minutes to boot. That was another point of frustration. And you said that you're lower level than the operating system in many cases. The crazy thing is sometimes when you're writing Windows drivers, you're in a higher priority than the memory pager, which means that you can't use certain types of memory because your code can't be interrupted. Like the processor is going to prevent your code from being interrupted in order to fetch memory from disk. So that means you have to do with only memory that is available in your RAM. This is hell. Like, if you can avoid it, please do.
Oh, I thought we were going to get a chance to talk about it. I mean, I have a bad anecdote one time about spending several.
Well, we can talk about it. I'm saying you should avoid it as a profession, but as a discussion topic, sure.
Several weeks spent debugging like an intricacy between a deadlock of two interrupts at slightly different parties that were not at the parties they were supposed to be, and one was interrupting the other, and it just created a sort of like cascade where it kept interrupting it, which would fill up the stack. But of course, none of that's obvious, right? And so, anyways, yeah.
I have a similar kind of story to you on. Patrick and I worked at a place where we did a lot of embedded, but I didn't do a lot of embedded. And so I was writing these kind of like, I was in a space where we had, gigabytes of memory. And so it wasn't an issue. And at some point, someone asked me to do something on a DSP. And I couldn't do it. I was like, I started like, I was like, oh, I'll make all these structures and I'll just have this like linked list and this tree and I'll manage everything. And then it's like, oh, your program won't actually fit on the chip. And I was like, wait, what? I was like, oh yeah, I guess the program itself takes space. And I was way out of my league. I was like, Patrick, bail me out. Somebody help me.
All right. So, okay, keep going. So you're at a cybersecurity firm, you're writing agents, so like things that run on the Windows computers and then get managed up. And then from there, sort of how did you, what came next?
Yeah. So by the way, after that, I once again vowed not to do any type of low-level programming and failed once again to keep my promise. But this time it's a bit more elective. So I do a lot of home automation, and I end up writing a lot of code that actually deals with hardware in my home. Sometimes I had to reverse engineer the protocols that they use. But anyway, so after that, I was with that company for about 7 years in total. It was acquired at some point. I stayed with the acquirer. But at the same time, I also moved to New York. And after leaving the acquiring company, I joined a small startup called Handy. And Handy is kind of like Uber for home services. So, you can book someone to come clean your home, or et cetera, et cetera. It was a very small startup, and we were like 4 people. And I joined as VP of engineering, and I was supposed to build an engineering team and start, making sure this thing actually works. And finally I'm in the clear and I'm writing high-level server backend code. I started hiring people, and once again I witnessed that coming out of college and not being prepared for work kind of thing now as a hiring manager, but very similar to what I experienced on my first day on the job. And I did that for a couple of years, and then once again transitioned to WeWork, where I was initially VP of engineering as well. That was a wild ride. That's material for a 90-minute long episode for sure. Probably way more than that.
Yeah, I think we'll just not have to go on to that one. Yeah, okay, keep going.
And did that and spent a few years at WeWork. That was actually really cool. We've built some really amazing tech. People always ask, why does WeWork even need tech? But I can honestly say that some of the things that we've built are groundbreaking. And, even things as mundane as making sure that key cards actually work. So if you've ever been to a hotel, you know that they don't work in like at least 20% of the cases. Whereas at WeWork, they always work, and you can actually switch buildings and switch companies and even visit a building that you're not a part of. And if you have a booking there, it's going to open. So we built a lot of really cool things, both software and hardware, to make these things work. And after leaving WeWork, I spent a few more years. I was 6 years at WeWork, and I've done more than just engineering at some point, and moved on to different roles. But after leaving WeWork, I did a very short stint as a VC. But the decided that the life of a founder is a better life for me. And that's when we started Wilco.
Okay, awesome. Well, we're going to come back to Wilco at the end, so we'll put a pin in that. And I think this observation that you made is people saying, "Oh, what kind of tech do you have to build for insert company here?" And I think that at some level, people say tech is changing the world and things are. But then this thing you're elaborating, like key card example, just as a thing is you think it's just a commoditized product at this point. But then, are you even mentioning about home automation? And most people's home automation experience just tell them it doesn't actually just work. And so you run into all of these for no fault of necessarily the product provider, but they're fine tuning for like a specific use case and sometimes overly so. And if you're just outside of that or two steps outside of it, you sort of end up on your own. They're happy to sell you their product and it'll do maybe the thing it says on the package, or you can hold them to it. But if you want to use it in a new application or a new way, you're sort of left out on alerts yourself and sort of adapting it or adding front ends or gluing it together in some way or interfacing systems. And that's a bit of a recurring theme. And so, yeah, I'm not surprised to hear you say that, but it is great to hear such a sort of, I think, understandable example.
Yeah, and that's what, makes, we're going completely off topic, but that's what makes build versus buy decisions so complicated, because sometimes you have a product that is, the leader in the space and supposedly great, but your use case is, like you said, just not the right use case for it. And, sometimes you can adapt what you're doing and then, just buy it and use it off the shelf. But sometimes what you're doing is unique and enough and not adaptable that you just have to build your own. And, you always have to be very careful to make sure that you're not, you don't have any, not invented here biases that are causing you to build this yourself. But sometimes it is the rational decision to, build something that already exists.
You are right. And I think making sure you've avoided the biases is a bit of a trick there. But yeah, it's very difficult. Okay, well,
Yeah.
to finally get
to avoid the biases, maybe that's a better way to phrase it.
Doing your best.
Yeah.
Okay, so finally, here we go. We're here. It's time. We're going to talk about this. So code review. We already, I think, even set it up unintentionally. Not that it was the purpose of the lead-in, but already sort of talking about students coming out of college, talking about expectations that are unobvious. I think several of those sort of tee us up or describe sort of code review. If you sort of type in, I haven't tried it. If you type into the search engine, define code review, I'm sure you get back something that probably adequately describes like the gist, but it doesn't capture the essence, right? Code review is a bit more than just the most obvious, like I show you my code and you grade it like a school paper. I think there's a bit more to that, and I think this is going to tee up the discussion. So I'll give you the opening argument here on, or your opening discussion about how do you think about code reviews?
Well, I actually like to start with a topic that's rarely discussed, which is why code reviews, right? And if, like you said, you type in code review into search engines, you're actually going to find a lot of content on how. These are the best practices when reviewing code. This is what we do at company X to review our code. But why are you using code reviews? And once you get into that, there's a whole world where you start to realize, wait, how am I even taking someone else's workflow when our motivations are completely different? And sometimes you'll find that even within a single company, the motivations for code review are different between teams. Now, if you ask most people, I would assume that a lot of them are going to think that finding bugs before they make it to production is a motivation for code reviews. And that's something I don't like, to be honest, because I think there are better ways to find bugs. Now, I'm not saying that if you find a bug in a code review, you should ignore it. I'm just saying that, finding a bug in a code review is finding it too late in many cases, right? You want to find those way before that stage. A code review involves another person. You want to find that before you involve another person, unless you're pair programming.
Yeah, I think just on that, before you keep going, I think that this thing is interesting. I've had occurrences where I've reviewed someone's code and missed a bug, and they want to share responsibility. They're so gracious, right? Well, you reviewed the code, and so therefore, you should have known it didn't do anything or didn't compile or didn't work. And I sort of, that conversation, that missed expectation about what was happening. But this thing is that even at the time, maybe I didn't spend infinite amounts of time and try to comb through it or redo all their own work, but sort of setting up those expectations and making sure that the team shares them. But yeah, this one in specific, like that, if you review your code, if you don't catch the bug, it becomes like your bug too. That's a bit of a hard arrangement to have.
Yeah, that's a bit extreme. But you mentioned the word share, which I think is really important in this context, because code review is a lot about sharing. And to me, one of the biggest motivations is creating that shared ownership of the code, not shared ownership of the bugs necessarily. And I don't think people should own bugs. I think they should own up to them. But it's about creating that shared ownership of the code. And this is actually something that both the reviewer and the reviewee can take, because if I'm reviewing your code and you might be working in this company or on this code base for 4 years, and I'm just coming in and I'm reviewing your code, I'm actually learning a lot through it. I'm learning, first of all, how are you used to working? And, maybe I'm used to a different workflow. And I'm learning about the patterns that you like in the code base. And I'm learning some of the gotchas that I might find in this code. So reviewing is actually a great way to read code, and reading code is a great way to familiarize yourself with the system, right? And you can't just go around reading code, but you can go around reading changes. That, is a great way, I would say, if you're starting, reviewing code is actually a great way to start. Now, some people might balk at that and they'll say, wait, but the person reviewing should know better than the person who's being reviewed. And you know what? That's not always the case. And in many companies, there's someone at the top of the pyramid, and someone needs to review their code, right?
AI. That's what we have AI for. No, I think this observation is great, and I think so. Two things. One is like you can have more than one person review your code, so there's always that. But I do agree with this. And the other thing, that being thoughtful about this when you decide how to group stuff for let's just say we're using a Git workflow or whatever, for a pull request, or that's what we're going to take. How do you decide when to stop and when to do that? And making sure that you are not just doing that for your own convenience, but for the convenience of reviewers. And further, I agree with this point that like doing it such that a new person has a sort of self-contained snippet narrative that takes them through, hopefully we're going to assume some good software practices here. Assumption is like you're seeing that maybe the person added a unit test for the failure that they were fixing, or a test for a new feature they were adding. You see the code that was changed. You see how many places and what parts of the system got affected by that particular feature or that particular thing. And it becomes this self-contained, encapsulated like description. No, not all pull requests would be like that, but I think a large amount of them can become this very like readable thing. And if you try to make sure you divide up your work in a way that the stream is readable, you're doing a great service to sort of the people who are coming after you.
Exactly. And if you need to familiarize yourself with a code base, that's a tough thing to do. And you probably need some combination of top down and bottom up, right? You need to understand the architecture of that code base, and that's the sort of the top down approach. And you see how things communicate with each other, which components are there, et cetera, et cetera. But then you also need that bottom up, sorry. And I think that reading past reviews is actually a great way to familiarize yourself with a given code base and the given practices around it, which are just as important.
I have, I'm not the best at this, but I have consulted old code reviews of myself or others for just remembering which pieces need to go get changed again, and seeing who commented on the time and said like, oh yeah, in the future, this needs to shift, or this. And I'm like, oh, I'm doing it again now. That didn't make it in the code. It isn't necessarily appropriate as like a code comment, but let me go back to the review that happened at the time and see, what did we discuss? What was our thought about, hey, next time we visit this, let's consider doing, and there it is. And so even if there isn't people on the team right now learning or in that stage, there could totally be in the future people reading your old code reviews and the process what you're writing in the code, but also how people are interacting with that process and observing it.
Exactly. So, that's one motivation, but I can think of so many other motivations that you might want to review code for. And, another one of these could be the quality of code. So you can automate some of that stuff, but some of it, you want humans to take a look at the code and say, all right, I'm going to perhaps assume that the code is doing what's advertised, right? But is it good enough? Is it maintainable? Is it something we want in our code base? And that's, another great motivation to have a code review. And there's so many different things. Is it secure? Are there any performance implications to what's happening there? So many different things that you would like to test in a review. And finding bugs, like I said, to me is way towards the bottom of the motivation. But, let's say that you've decided what your motivation for code reviews is. As I said earlier, it doesn't have to be consistent between teams, even with the same company. So at WeWork, for example, we had a billing team. They were building a product that billed our customers. And when you bill your customers, you need to make sure that everything is super accurate, and you need to make sure that everything complies with tax laws, et cetera, et cetera. And the code review process is actually very long, and some of it is actually regulated. You have to make sure that to meet certain sets of compliance rules, the review needs to go through some process, et cetera, et cetera. But then you have another team that might be working on the front-facing website and wants to iterate quickly and get experiments out there. And, if anything bad happened, they're just going to roll forward and fix it on the go. Why would those two teams follow the same process? They start with different motivations. It can't be that, what I'm seeing in a blog post about the best way to do code reviews applies to both of these teams equally, right? I mean, there has to be some sort of adaptation to the specific motivations you have on your team.
Yeah, maybe a poor analogy, but someone brought something up the other day that I think like applies here or whatever. That if you take folks who work with wood, someone who like frames a home and someone who builds fine furniture, they may both use a hammer, they may both use a saw, but like they don't use them for the same purpose. Like sure, to cut wood or nail a nail, but like if you're doing fine furniture, like the delicacy and like force you're going to apply are very different than someone who has 783 2x4s to put together to make your house. Like what happens if you miss, right? Like, oh, I hit the 2x4, who cares, it's going to get covered up, versus like I'm driving in this nail into this $1,000 piece of wood or whatever, right? Like you may both say, oh, they're both hammering, they're both doing carpentry, or I don't know if that's the right word for it, they're both doing woodworking, but to your thing, the motivations are entirely different, and the way you would judge their performance shouldn't be the same.
Yeah, you're absolutely right. And you know what? This actually happened to me when I showed this design to a carpenter that's doing furniture. And he looked at it and he said, this looks like someone, who's building homes designed this. This is not the way that you would design a piece of furniture and not the way you'd assemble it. So, he had a beef with the inside out versus outside in of like connecting, the pieces of wood together. So you're absolutely right. And I've seen it firsthand.
And I think like to bring it back, I mean, I think this, your illustration, maybe people don't realize that actually, that there are certain accreditations or sort of standards of safety or privacy for things like medical or whatever, where actually the artifacts, the code review itself becomes like a thing that should be recorded and processed to be followed for auditing purposes later. It's not that an external auditor is going to look at every one of your code reviews, but they want to be able to look at one of them and they want to see that it's always done and that it's not rubber stamped, right? That thought is put into it, that time is taken. And that's very different than, like you mentioned, hey, I got to get this hot fix out to the server in 37 seconds or we're going to lose $1 million on the, whatever, right? Like those two things shouldn't follow the same sort of code review.
Yeah, I've seen auditors, sample code reviews and look at them. And if you look at a code review like that, if one of the fields is missing, sample through your code reviews. We've had that. I've seen that. And when that happens, you really want to make sure that the code review, everyone's dotted their I's and crossed their T's, and there's no missing field if there's a specific structure to those reviews, etc. But then if all you want to do is move fast and break things, potentially you could be skipping, some of the things. And maybe this thing that is supposedly mandatory on our code reviews, we're actually fine with dropping it every now and then if we think like there's good justification. So the level of leniency could also change according to what's the impetus for the review.
Yeah, so I think these callouts are awesome, right? Like, not only about fixing bugs, about using it for the right sort of task at hand. Like, is it rigorous, audit compliance and has like a very specific format, or is it more sort of go super fast, or is it a kind of middle of the road? I assume most tests are probably kind of the middle of the road ones, and sort of making sure that all of the right bits and moving parts are in place for a code review. And sort of like you said, I think there was a great call out. It's I don't want to say a pet peeve of mine, but something that I also do. So like, it kind of sounds dumb. One thing I screen for, like we use C++, and I screen for people using like, I don't want to say banned parts of C++, but like getting too cutesy with their C++ work. And I'll come in as sort of like, having been around a bit longer and sort of say like, no, actually, like for maintainability purposes, please like don't do this clever, weird template metaprogramming trip and just like, write it out. And so it sounds kind of goofy to kind of do for that purpose, but it's about making sure that the style and not the linter style, like you were alluding to other tools to do the job of checking that code compiles, linting. We didn't say those, but oops. And so, or, sort of saying, or sort of saying that, like, for me, it's that higher level stuff that is a human stylistic choice. Like, how are you choosing to decompose your functions? How are you, structuring your code in a readable way? What paradigm are you applying here? And that's where I'm sort of looking for in part when I do my reviews.
Yeah, eventually, we spend more time reading code than writing it. And definitely reading code is a more important skill than writing code. And you get to use it in a review, right? And when you read that code, you need to make sure that others can read that code too. And what you said about those C++ tricks is great because, in many cases, you can actually read that code and understand what it's doing in a split second, but that other people looking at it are going to have a hard time and are going to struggle with it. So sometimes you have to kind of look at it from the point of view of someone who's not necessarily at the same experience level as you. And when I say experience level, this could be, not just an experience level, generally speaking, but experience with a specific product or a specific code base.
Yeah, I think another one, just to like chime in on while we're in this vicinity, that I've done recently is, and maybe it's people could debate if it may. Oh, let's see what your opinion is, if it belongs in the code review or in something else, which is, someone sort of made a choice that was a choice. And I sort of put to them like, hey, we have two ways in the code base of doing this, like, this way A or way B. And we used to use only way A. We've started introducing way B. You're writing this utility and this sort of like, oh, like what is your decision mechanism that you're choosing here to do way A instead of moving it to way B. And then we sort of had a little bit of a discussion where other people could kind of chime in, which is, hey, we're writing this code, we're trying to move to a new way. Like what is the rubric we're using to follow about how to decide what technology to use or which place? And I don't know actually if that's appropriate for a code review. I mean, I did it in a code review. Shame on me, maybe. But like, maybe you're going to burn me for it. But like, I think like to me that was an interesting, like, it made sense because it was in the place where it was happening. But I'm actually like unclear if that's does everybody see that on the team? Like, is it the right place to do it?
So I think that, once you've encountered a practice that you think is no longer the recommended practice for that team, then calling it out during the review definitely makes a lot of sense. But depending on how big the change is between those two ways of doing that, could hint at, the fact that it should have been discussed earlier, perhaps in the same forum, perhaps in a different forum. But if the different way is we're no longer doing I plus plus, we're doing plus plus I. When we're incrementing a counter, that's fine to do in a review. That's okay. But if the new way is, oh, by the way, we're no longer using remote RPC. We're using RESTful endpoints. Maybe that's too late.
That's a great, like, I don't want to say phrase, like almost fits on a t-shirt, maybe not, but like code review sometimes is too late. And I think this is like a piece of tension between someone not letting people know soon enough about a controversial decision, letting it go to code review and hoping that like they've passed the decision point and it'll just sail through. But the reverse is true as well. Other people hoping to like exercise a new agenda or whatever, trying to catch people in code review and forcing them to really take on more work than is appropriate when they had budgeted and they thought time was done, and now like they're faced with a large change.
And when you say that, it there's an important point to be discussed here. Code reviews are probably one of the most common and sometimes one of the best examples of combining soft and hard skills. So a code review is not just about code. It's an actual process between humans. And like you said, sometimes people might be looking, might be out to get someone else in a review, or might be trying to slip something past the reviewer. But these are just, two things you might find. But there are so many other patterns of human behavior that you can find in reviews. And reviews could be very contentious because of that. That's where developers, who in many cases have large egos, come in and sometimes have conflicting interests and have to sort it out somehow. There's room for a lot of anti-patterns in here. The two that you mentioned are just two examples. There are so many others. It's scary when you think about it.
Yeah, I think one thing I've tried to, I don't say promote, I've tried to encourage people is, and I think you were alluding to this early on in part, which people think about the tool of code review, whether it's like GitHub or some other, whatever tool you use, code review, and that tailoring it to the needs. But I would say like to the review can happen as well. You don't want to tailor every review in a specific way, but there are some changes which I will tell people, look, you need to socialize this before you put it up for code review. Like you need to go talk, like actually go to someone's desk or schedule a video conference call with them and have a time to walk through so that they feel comfortable in doing the review, that they understand what's happening. It's not that that change is necessarily avoidable or bad. It may just need to be that way. It's a massive change, but give people a heads up. And that in itself is still code review. Like you are reviewing that code, but you're not using the code review tool, right? Like you're splitting the sort of the why of code review into different parts. You may still go through the formal process of having someone approve it, but it might be a relatively empty, amount of requests or changes to be made. Why? Because you did them up front, because you had someone go through it. And the one I'll call out here is like people like to do that with interns. Like wait till an intern gets almost to the end of the internship, have them drop off a bunch of code and then like red mark the heck out of it because they didn't know this is the style or this is the whatever. And I'm like, no, that's really, like you said, soft skill. That's a really bad soft skill practice. Like it's really frustrating. And the second thing is like, you probably knew in advance that was going to happen and you let it get that far. Like you should have just gone to them and said, hey, can we sit down and look at your code? Can you put up your branch and let me look at it? Whatever the right, technology.
Yeah, you want to set people up for success with their reviews. And if people are getting to the review in their last day or last week of the internship and everything is red marked, then that in a way that's sort of a waterfall approach, right? You let them write everything in advance and then it goes to the review stage where everything is happening, and then afterwards it's going to go to the next stage. That it's very waterfall, and waterfall is considered bad practice these days, and for good reasons. But it doesn't mean that you shouldn't be discussing things before you write them. It doesn't mean that every change is the same. And the size of the change matters. The impact that it has matters even more. And more importantly, like you said, the the motivation that people might have, or their desire to succeed in getting their code into production also plays a part in that.
I think we could probably go at length for code reviews and pontificating or soapboxing, but I'll try to land. Let's try to land this aircraft down, which is,
Sure.
I think, as you mentioned, like we haven't even. Well, I guess I did. You didn't, but we haven't talked about the specific tool or the how of code review. Instead, we sort of explored this topic of why. I know there's probably tons more you like to say, but any sort of like
Yep.
final things we kind of didn't get to, or sort of things you want to call out.
Well, just the fact that it is an interaction between humans, and you need to be careful in how you conduct yourself, just like any other way. People tend to think that what I write in a code review is not like a regular conversation. I can be snarky, I can be offensive, I can just be a bad colleague. Well, guess what? You can't. It's another form of communication. You need to be respectful. People have worked hard to do what they do, and even if you don't agree with it, and even if you're right, it could be because the other person is used to a different team that was working in a different way, and they could be right for the context that they're used to, and you definitely should assume that they're not doing anything bad on purpose. So just code reviews are probably the easiest way to get to developers at each other's throats. So just keep that in mind, and be careful.
Yeah, such a great observation. I mean, I guess to use your sort of quip from earlier to your interviewer asking about what's a context switch, like, are you serious? Not an appropriate code review comment. Like, are you serious? Like, I have seen stuff at that level. That's not a sort of like like go to them, like send them a Slack message, schedule a meeting. Like you can have, it's not some violation of some inviolate like contract that they pull down the code review, change something, and put it back up again. Like, it's perfectly fine. And so you are right. Like, I have seen way too many people get at each other's throats because someone was grinding it. There's a cultural norm to establish and help shape. All of us, every time we do it, are subtly influencing the team's culture of code review. And new people especially like have to get onboarded to that process.
And don't get me wrong, I've had my fair share of arguments over code reviews, and I'm not perfect, and I've made many of the mistakes that I try to preach other people not to do. But as you do more and more of these, you start seeing the patterns in advance of a conversation not going the right way. And if you're the more senior of the people interacting in that review, that is your responsibility at this point to figure out that the conversation is not going in a productive direction. And that is perhaps the time for you to maybe take it to a different medium where you can discuss privately and reach some understanding, and then come back to the public conversation in a better mood and less argumentatively. Is that a word?
Argumentative.
Argumentative, yeah.
Yeah, that's such a good point. I mean, I think the one thing I tell senior folks is, if there's two junior folks or more junior folks, arguing about something, like they're sort of in a competition in a sense. And you as a, staff engineer or a principal engineer, like you've already won in this sense. Like you've already gotten the thing that these people want to have one day. And so, taking that approach of saying, look, you've already won, and you can't unwin. Like no one's going to down. I mean, I've never heard of a company down leveling an engineer. I mean, the fire people before they down level them. So it's like you've established yourself, and so now, like, if you can make a small sacrifice to really like bring these people together, that's really something that you're uniquely kind of positioned to do, and that's something that I think is could be difficult for people as they kind of move up to understand that is something that they're uniquely positioned to be able to provide to the company.
But eventually that's what their job is, right? If you're a staff engineer, one of the
Yep.
responsibilities that you have is making everyone around you better, all the other engineers.
Right.
So if they don't understand that, maybe they should be down leveled. But if
Wait a
they
minute.
do understand,
I have read a lot of articles on Hacker News about what makes a senior engineer. I don't recall reading a lot about empathy or sacrifice or what are you guys talking about? That's not what makes a senior engineer.
It's just like the college thing, right? They teach you the wrong things.
Yeah, all the people who chose spaces became senior. That's
I
how
have to admit, though, Jason, I'm envious every time you speak. You have such a good microphone, and I'm on my crappy headset.
Patrick and I when did we get microphones? Like 5-6 years in? I don't even know how that happened.
And then I reverted back from I'm too lazy.
Well, yeah, since you moved, right? It's probably still in a box somewhere.
Somewhere. I got to dig it up. All right. Well, that has been an awesome exploration. I know there's more to do, but I'm gonna just put the sort of period at the end of that sentence, whether we should have or not. But let's talk a bit about Wilco. So we sort of put a pin in it in the beginning. We're coming back to it now. You saw a need for a startup, right? I mean, like ultimately, maybe I'm presuming that's what founders tell us, right? Like I saw a need, I saw something that was not there, and I was uniquely suited or so passionate that I needed to go build it. Help tell us like why Wilco?
Yeah, sure. So if you take a lot of the points that we discussed today, you realize that there is a mismatch between what people learn and what people are actually doing as software developers. And it doesn't matter what level. I mean, like you said, you've read all these articles on what a senior engineer should be, and most of it is about code. But code is just one skill out of many that a good software engineer needs. And college doesn't teach them that. Boot camps don't teach them that. And eventually, developers need to practice. And the only way to practice is on the job. But when you practice on the job, it's A, very slow. It's B, very error prone. And C, doesn't provide equal opportunity. So much depends on which team you get to and whether you had the opportunity to get into a good team. So what we said is, what if we give developers a good way to practice? And when we say practice, we mean all of the skills, not just code writing. What if we give developers a good way to practice that is safe, that is in their own pace, that depends just on their merit? And we came upon this idea of giving them or letting them join a fantasy company. And that company has a production-like system with logging and monitoring and analytics and load balancing and a real data set, not just 5 records in a single table. And it has the biggest mess of all, which is people. So you have colleagues and you have team leads and product managers and stakeholders and all of that. And on top of that, you start going on simulations or adventures, or we call them quests because we're so influenced by 80s video games. So you start going on quests, and a quest could be, we have a performance problem in production. Please figure out what happened, what's the root cause, what's the extent of the damage, fix it, and communicate it to stakeholders. And the focus is not on fix it, because you can learn how to fix it in college or at a boot camp or even online. The focus is, how do you even know that something's wrong? What do you do to investigate it? When do you go for a quick and dirty fix? When do you go for something more meaningful? How do you ensure that lessons are learned and implemented? And that's definitely something that's not covered anywhere. And all of these tiny things that you really only pick up on the job. And that's what we're trying to help you do with Wilco.
Yeah, I mean, this is, you're right, like such an uncovered, people make quips about sometimes like, maybe I only wrote one line of code, but the hard part is figuring out what line of code to write. And I think, once you know what it is you're trying to do, I mean, we make that joke, it's just Stack Overflow or whatever, right? Like you just go to Stack Overflow, like how to turn off, database backups and, during peak performance or whatever. I don't know, making something up. But knowing what to Google is sort of this like untaught, very long lead time, long iteration.
Or even knowing that you should Google.
Oh, there you go. Fair enough.
I mean, let's say I changed the database schema. It's no longer the same. Should I do something about it, or should I just, go to production and everything would be okay? Well, turns out most people early in their career are probably not going to search anything about it. They're going to assume that, I just added an index. Everything should be fine. But then it goes to production and the database is halting and nothing's working. well, you should have Googled it before, and now it's kind of too late. So it's not just how to Google, it's even when.
Yeah. This too. We were joking about senior engineers. This like on the job hard knock training about like that building up that intuition a bit. And it's great to hear that. I think maybe I call it intuition, but actually you're kind of calling it no wait, this isn't that. This is some unteachable, unknowable thing that actually put into the right circumstances. There are some commonalities here, some simulations where we can put people through and sort of have them kind of realize that themselves.
Yeah, I mean, like they say, the way to Carnegie Hall is practice, 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 right? So it's not just for music. It goes like that for every type of profession, and software engineering is no different. You need to practice, and practicing actually allows you to develop intuition. Musicians that improvise practice a lot beforehand. It's not just that they go out and improvise. They learn the basics, understand what are scales and how they fit with each other, and how melody and harmony work together, and then they can start improvising, right? And same goes for software engineering. If you practice enough, you'll develop that intuition that allows you to do things or know when things might go wrong and when things are pretty safe. You might still get it wrong, but at least in most cases, you'll get it right. And, we've actually seen other professions do something similar. So one of the things we looked at as we were working on Wilco is this thing called CTA, which is cognitive task analysis. And what we've seen is that firefighters learn the theory of fires and what to do in an incident, but then they go to an incident and they might not necessarily be able to apply the theory that they've learned, whereas a firefighter with 20 years of experience gets into a scene and knows exactly what to do and how to do it. But they can't teach it. And what CTA does is it tries to extract that knowledge, that expert knowledge, and turn that into something that could be handed off or could be taught to other people. And that combination of intuition, experience, wisdom, some people call it, is, that's the elusive thing that we're trying to really give you with Wilco.
This observation is really good that other fields do. I have some family in the medical field, and one of the interesting things is part of their degree is doing on the job sort of, internships, as it were. I guess they call them other stuff. But they also do simulations where they bring in actual patients who have like a set of things they're supposed to say. And you say, oh, that's just testing their knowledge. But actually, you can have something that sounds exactly like a very esoteric disease. But I think there's some phrase for it. I'll misquote it, so I'm not going to say it here. But the point being, like, there might be a much more mundane answer that could manifest the same way. And that's the one you should test first, not jump to the 1 in a million super rare mutation disease.
Yeah, because all of them watched House and they think that, that's the life of a doctor.
Yes, because everyone comes off that training. And so it's this thing you said, which is one, extracting the knowledge, like teaching flows. They call it like differential diagnoses. Like, how do you decide between A and B? What is the test to apply? What is the choices? But then also not stopping there and teaching it, but actually putting them in a more complex, more messy case with real humans who don't describe things accurately, or no, I don't have a cough, and sort of like, yeah, you're getting contradictory inputs. And so what do you do then?
A friend told me once, he gave me a great analogy. He said that if he wants to understand the state of the art in medicine, he's going to go to someone who just graduated med school. But if he needs someone to operate on his shoulder, then he's going to go to a doctor or surgeon with 15 years of experience. And that surgeon might actually know less than the recent grad, but they've been there, done that. And software engineering is like that. There's a difference between knowing the state of the art and actually being able to practice it.
Well, cool. All right. So tell us a bit about Wilco as a company too. So we talked about it as a sort of product and solution, and sounds very engaging. And we'll include it in the show notes, but you can go to trywilco.com and check it out. But talk to us about Wilco as a company. Are you guys hiring interns? Like, what is the kind of behind the scenes of creating these quests? It sounds really interesting. Like, how is all that powered?
Yeah, it's I'm biased, but I think it's really cool. And writing a quest, is a combination of understanding the skill you want to practice or the lesson that you want to convey, but also tying that into a narrative and making sure that it's part of a curriculum. You can go in Wilco, you can practice all sorts of things, and it's not, you use your own tools. So, you're going to use your command line, you're going to use your IDE, but you might be using an observability tool, for example, because you need to maintain production. That's something that you don't do in college, right? But it's not just for college grads, right? You might be doing 20 years of programming in a different field, and you're coming into something new, or you're just looking to practice. So you're going to, touch upon different tools and all of that. And of course, you could also be building your own. So we don't have it just yet, but very soon we'll have an editor where you could be writing your own quests and contribute that to sort of the Wilco ecosystem. We already have companies that have built quests and they're on the platform, but in the future, we'll open this up to individuals as well.
Very cool. Very cool. Do you guys, for hiring, are you looking for people who are like strictly like very senior established and ready to sort of impart what they've learned, or you're looking for up and coming people to help build out the things that build I guess it becomes a eat your own dog food kind of thing. Well,
Yeah,
where do you guys kind of do most of your hiring?
Since we're, all about developing developers, it would be very hypocritical of us if we wouldn't be open to people of all experience levels. And we think that Wilco is a great way for them to bridge that gap and very quickly gain experience. So we're really open to all experience levels, but this needs to be people who are, that are passionate about furthering the skill or the craft and becoming better developers. I think most developers have that intrinsic motivation. So, that's the kind of people that we want on our side. And actually, being inexperienced in many ways has sort of an advantage of, being able to call out things that we take for granted and might be tough on, people who don't, we haven't exercised that skill or learned that area.
Awesome. Well, this has been a great conversation on,
Thank you.
We covered a lot of ground. We put a lot of side tracks aside and sort of, we tried to stay on track a bit, but.
Sidetrack is my middle name.
Oh, there we go. Oh, I see what you did there. Okay. Where there's our pun of the day. And so thanks for coming on the show. I think people are really going to like this. I think it was a thoughtful thing. As a junior engineer, I made a lot of really dumb mistakes. Sometimes I wish I had the exposure to the things I think are around now.
Me too.
But to be honest, probably wouldn't have paid attention to them. So, but maybe we'll catch the person who thinks they don't need it, but maybe kind of puts a bit of extra thought into it today. But yeah, great advice all around. Thanks for being on the show. I think it's been an awesome time.
Thank you so much. It's been really great, and thanks for having me on the show.
All right, we'll see everyone next time.
See you later. Music by Eric Barndollar. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution